Hey Logic 1, hope you guys are doing well. So today we are going to do lesson 101, which is translating expressions into equations. So to talk about this, there's a couple things we need to know before we dive into the math. First, we have to understand what the actual language is telling us. So math is its own language. It communicates in quantities and in relationships, in logic, and in problem solving. And one of the biggest things that we take into algebra and take out of algebra is this idea that we can translate numbers and variables and expressions into equations. So what that means is, first, to translate means to take from one language to another to make sense of. And if you remember, an expression is any combination of letters, well, that's not a letter, sorry, numbers, operation, and letters. So here we have 2 plus x. The reason why this is not an equation is because there's no equal sign. There's nothing to balance the other side of this expression. So an expression does not have an equal sign. An equation does. So expressions into equations means we're taking that expression and we're going to put it into an equation to make sense of the variable so that we can find out what the missing factor or the unknown variable is. So you'll see at the bottom of your page all of these examples of how we translate an expression into algebra. So if we were to say twice a number, really that means 2 times that number. Our unknown is right here, a number. If I were to say twice 3, that would be the same as 2 times 3 or 3 2 times, twice 3. But here, we're talking about 2 times a number. If you look at the next example, it says 5 more than a number. Here we have our unknown, which is represented with a number. We know that whatever number this is, we are adding 5 to it because it is 5 more than a number. The trickiest one, in my opinion, is subtraction. When we say 3 less than a number, we're not saying 3 minus this unknown number. In fact, what we're saying is that number first, taking away 3, because whatever the outcome is going to be 3 less than the original number, which is n, or a in this case. Half of a number would be 1/2 n, or h divided by 2. The product of a number and 7 is the same as what we had up here. We're multiplying. Again, that keyword is product. And 17 is 5 more than twice a number. Now, here's where we introduce an equation. Here you have is, and that's a big key word. Is means equals. And what this is telling you is that 17 is equal to 2 times a number plus 5. So let's go ahead and flip the page, and let's go ahead and practice this. All right, so let me pull this over a little bit. There we go. Sorry if it's a little tight. So let's go ahead and look at this example right here. If 5 less than twice a number is 17, what is the number? So it's asking you here to find the unknown. So let's go ahead and translate this expression into an equation. 5 less than twice a number. So we know we're starting with twice a number, unknown. 5 less than that is going to be minus 5 is equal to 17. So now let's go ahead and solve for x. So we draw a line down the equal sign to represent 2 sides. We're trying to isolate this term right here, 2x. We're going to apply the opposite of negative 5, which is positive 5. Whatever you do to one side, you have to do to the other. We've done nothing to 2x, so we're going to bring it down. 2x, negative 5 plus 5 is a 0 pair, so those cancel out. Bring our equal sign down. 17 plus 5 is 2. We're not done yet because now we still have 2 times x. If these are being multiplied, the opposite operation is division. Whatever you do to one side, you do to the other. We know 2 divided by 2 is 1, so we're going to put x. Again, whenever you have a variable by itself without a coefficient in front right here, you can always assume that it is 1, because 1 times any number is that number, and x is 11, and that's what you get here. Okay, so now let's also apply this to geometric relationships. So here we have a supplementary angle, 2 angles. We have 2x and x. We know that the sum of these 2 angles, because they're supplementary, is 180. So, oh, do you know what I just realized? You guys, I'm not recording it on your page. Okay, well, hold on. See if I can fix this.
Mommy?
Oh, there we go. So sorry about that. Let's go ahead and clear this board. All right, now let's come back to what we were talking about. This guy right here, the angles marked x and 2x are supplementary. It even tells you that in the word problem. So we know that 2x plus x is equal to 180. Equal 180 degrees. So we can add like terms because these have the same variable. So 2x plus x is equal to 3x. 3x is equal to 180 degrees. So now we're going to divide both sides by 3 because we're trying to isolate x that's being multiplied by 3. 3 divided by 3 is 1, which clears up x. And 180 degrees divided by 3 is 60 degrees. All right, so you just translated something that is geometric in nature into algebra, and that's going to be a huge, huge skill that you're going to use as you go into algebra and then into geometry. All right, let's drag this away. Okay, so guys, now you have your lesson practice to do. Please do those. Make sure that you get it checked by a parent, and then hop onto your mixed practice for the rest of your lesson. Okay, good work, guys.